Hello everyone, this is the last topic in Unit 1 of Predictive Analytics, that is Perceptron Learning Algorithm. Okay, the Perceptron Learning Algorithm is a binary classification algorithm used in Predictive Analytics. It is a type of supervised learning where the algorithms learns to classify inputs into two categories based on the training data. Still now we have completed classification in linear discriminant analysis, and next we have done with our logistic regression, and now last we are doing Perceptron learning algorithm. Okay, in two categories it is going to classify. First one, initialization. Initialize weights and bias to small random values. Okay, next what we should do, input signals. Input features are multiplied by their respective weights, sum these products and add a bias. Okay, next, activation function. What is activation function here? Use an activating function, often a step function, to determine the output of the Perceptron based on the weighted sum. These three are the steps we are using in Perceptron learning algorithm. Okay. Error calculation. Calculate the error by comparing the predicted output to the actual output from the training data. Everything done in the Perceptron learning algorithm by training data only. Update weights. Adjust weights and bias based on the error using a learning rate. This step helps a Perceptron learn from its mistakes and improve its accuracy. Okay, this Perceptron learning algorithm is learned by its own only. Okay, it will learn from the mistakes and improves its accuracy. Iteration. Repeat steps 2 to 5 for multiple iterations or until convergence. That means you should repeat it continuously. When we are repeating, some outputs will be different, some outputs will be same. Okay, this is a picture of the Perceptron learning algorithm. First is the x1, x2, xn are the inputs. For that inputs will give some particular weights, that is w1, w2, so on, wn. Then after we'll learn from the experiences and you'll get the output, that is y. Okay, and the more accepted convention here, y, if y is equals to 1, if 0 or x is equals to 0. These are the conditions we'll get when we are training the Perceptron learning algorithms. Okay, next let's see an example with all the steps before we have learned in the algorithm. Okay, imagine you have a data set of flowers with two features, petal length is x1 and petal width is x2. The goal is to predict whether a flower belongs to the species A1 or species B0 based on these features. Okay, you should compare which flower belongs to which species, or either A or B, by what we are predicting with the two features, that is petal length and the petal width. Okay, first one, initialization. Start with the random weights w1 and w2 and a bias b. Okay, this is your choice, you can give any weights to it. Okay, input signals. For a flower with petal length x1 and the x2 width, calculate z is equals to, this is a formula to calculate the input signals. For every example you can calculate by using this formula. This weights w1 and w2 is your own, and b also your own only, you can take a numerical value. And here they gave x1 and x2. Okay, this x1 and x2 you should find here. Okay, next, activation function. If z is greater than or equal to 0, predict species A of 1, otherwise predict species B 0. Okay, next, error calculation. Compare the prediction with the actual species label 0 or 1 to calculate the error. Okay, next, update weights. Adjust weights and bias based on the error to improve the model accuracy. If comparing with both the petals width and the length, if you know that it belongs to a species A only, you can improve. Means you can add the bias and weights furtherly differently. Okay, means you have added the w1 and w2 by your own, right, and bias also. After adding that particular weights and particular bias in the previous one, what will happen? It will show some output, but you are thinking that it maybe belongs to species B also. So what we'll do, you can update the weights and you can update the bias also. Then you will get the model accuracy to improve the model accuracy. Next iteration, what you'll do in the iteration step, repeat steps 2 to 5 for each flower in the data sets until the model convergence or for a set of iterations. Okay. Next, types of Perceptron learning. What is types of Perceptron learning here? There are mainly two types of Perceptron learning, that is single layer Perceptron and multi-layer Perceptron. In single layer Perceptron will consist of a single layer of outputs nodes that directly produces the final outputs. Next, primarily used for binary classification problems, limited to solving linearly separable problems. It uses only single layer of outputs, whereas in multiple Perceptron it uses the multiple interconnected nodes including inputs, hidden and output layers. Can handle more complex problems and non-linear relationships between the input and output. Okay, means in the single layer Perceptron it uses the only single outputs. In multi-layer Perceptron it uses the multiple interconnected nodes including input, hidden and output layers also. Okay, thank you.